Okay, so last week we've been working on LVM. What is LVM? Logical Volume Manager. Okay, so let's take a look here. Okay, so we have three physical drives: SDB, SDC, and SDD. Okay, so let's do LSBLK. So we have three drives, right? SDB, SDC, SDD. Okay, so these are the three drives here. And then we what we did is we used a pv create command and used up all the drives here. So right now the size of our volume group ZMPT1 is 40 gig. How is it 40 gig? It's three drives here, uh, 8, 16, 16. Okay, so we have used these commands to arrive here. Okay, now what we are doing here, we want to have the different partitions here. Okay, why do you want to have a different partitions? Because these are all going to be used by different groups, which is accounting, human resource, finance, recruiting. Okay, can one of you confirm if you could hear me?
Yes, we can hear.
Okay, good. All right, so okay, so uh, the command to create a logical volume is lv create. So okay, so command is lv create hyphen n. N stands for new. Okay, and then what do you want to give the logical name? Accounting. Okay, and then hyphen l, that means you keep making it a logical volume. And what is the size you're making? You're making 4G. Okay, and then where are you getting this info? Where are you getting this volume name from? We are taking this out of volume group. Okay, and hit enter. Okay, so let's see here. Let's type BLKID, and then let's see here, dev mapper type swap. Okay, so even though we haven't formatted it, since it's a part of a volume, it does have a UUID. Okay, UUID usually comes when you format it. Okay, and at this moment it's using the type LV2. This is what kind of type is the partition here, but I think we're gonna change that here in a moment. Okay, okay, so let's create hold on. Okay, in here what it did was, you are seeing a lot more information here. It created a 4 GB volume here, but right now it's resting on SDB. Okay, let's say go ahead and create three more. Okay, three more, which is the human resource, finance, and recruiting, all 4 GB each. So let's see how that's gonna work. Okay. Finance and recruiting. Okay. All right, good. So I'm going to go here. All I'm going to do is change it to human resource and hit enter. I type LSBLK. Okay. So now it made the logical volume on SDC. Okay. All right. Let's do finance. Okay, and hit enter. Okay, then let's do LSBLK. Okay, so obviously it took another 4 GB out of SDD. Okay, and here's the trick comes in when we're gonna do a recruiting here. Okay, because it has to go in one of the other. It probably will go to SDB. Okay, so now what it did here was it went to two of them. It's sitting 4 GB on SDB and 4 GB on SDC. Okay, but while 4 GB and 4 GB, it's 8 GB, right? But it's not actually taking that much space here. What is happening is it's actually spread out. It's actually spread out during the over these volumes here. So if a hard drive fails, this thing doesn't mean anything. What it means is if this physical logical volume LVM, if this one goes down, then all these things, all these partitions have going to be have problem. Okay, so we'll see how this is going to play out here. So at the same time, what we did here previously, we had different kind of partitions here. We could definitely go ahead and do that on this also. Okay, so what I'm going to do is I'm gonna use this as a ext4, two of them as ext4 and other two as xfs files. Okay, what is the command for what is the command to do this? mkfs dot ext4. Okay, so now the challenge comes in, what is the name we're going to give? Okay, what is the name we're going to give it to format it? It was nice and easy previously here. It was nice and easy, right? We were just giving the name of the partition here, dev/sdb, and there is a first partition would be sdb1, second would be sdb2 and 3. Okay, so how are we going to do that? Okay, so let me go in here. You're going to cd/dev. Okay, and let's see what we have here. Okay, we should have a folder named ZMPT right here. Okay, so there is a folder in here which is called ZMPT1. Okay, let's go in there. Let's see what we have here. Well, there you go. Okay. Now, what we did here, we made a partition here, right? It's acting as a folders here. This is what is actually running this as folders. Okay. In the start of the class, I said folder is also
A file.
okay. Great. Very good. Very good. Now you'll get to understand why I said Linux is file based. Everything is running as a file based. Okay, now we have accounting here. Let's see if we could go into accounting. Okay, so we can.
Are these folders are soft link that the greater than sign means that it is soft link to DM-2 and DM-4?
These are soft link, yes. How do you know these are soft link?
The symbol, soft link symbol, and pointing to the parent directory is /DM-2.
Yes.
And if you look at the permissions, the link is started with the L.
Yes. And also the color.
True.
Okay. All right. So very good. I'm impressed. You guys are doing really good here. Okay. So let me get out of here. So now I'm going to format accounting as ext4. So what is the command? mkfs dot ext4. Okay. Then okay, hold on. Okay, I did pwd here and ls. Okay, so let me get out of here. I'm typing mkfs dot ext4. Okay, and what I'm going to type here next? Okay,
Slash.
yeah, I'm going to type this information here.
Correct.
And then slash accounting. Okay, and I'll hit enter. Okay, let's do blk id. Okay, now you see that this is it in itself is a partition now, and that partition has a UUID, and now it's telling that what is the type. Type is ext4. Okay, all right, so let's try the second one, human resource. Okay, and I'm hitting enter. It's gonna do the good same thing. Okay, now the other one, I'm going to make it a XFS file here. So I am on a different computer. So let me see if XFS is installed. Okay, it's not installed here. Remember, guys, on a Red Hat 7, it's already installed, and XFS is already a default. And as well as ext4 is already installed on it. If you want to create a ext, you could create that too. Okay, so here I'm going to download it from the internet. Okay, so I'm connected to internet, and the command is yum install xfs. Uh-oh. No package available. All right.
I believe we tried last time as well. Either we installed or we tried, at least we tried.
There's a command in the notes for installing XFS.
Okay. All right. Thank you. Okay. Yeah. Right here. So it's actually not XFS. It's something else. Okay. So there is another command here. You could find out which XFS file we really need to do it, right? So if you know, I did which XFS. All I did was when I type which XFS, it tell me it's not installed. Okay, but you could type yum provides XFS. So what it's going to do is it's going to go onto the internet and find out if there is a package for XFS. Okay. Okay.
But Zafar, how does it knows that what package name would be in this yum provides XFS?
It goes out to it's going out and hitting these servers here. These are very, very well maintained, trusted servers.
Okay.
And we're gonna go a little bit deep in this when when I'm gonna cover yum repository and downloading and setting up the local repositories.
Okay.
I'm gonna work on that here, but it's just a wrong time to. I was trying to avoid this here, but there is no way to avoid this until I showed you the real thing. But we don't have any choice. But anyway, since we have already figured that out, I mean, don't hesitate to use Google when you are at work, okay?
But we shouldn't say to use Google, right? The interviewer, some of them, depending on the situation, they don't like you saying Google.
No, you just say, I will check with other resources.
Right, okay.
The moment you say resources, it could be anything. Your coworker, somebody offshore, anybody. Okay, so let's see here. XFS package. Okay, here, which package provides XFS? Okay, here is asking for a login. Usually, okay, package is this, and then mkfs is not available. Okay. I think this is the site we went first. Okay, here is telling you could install yum, install these two packages. I think this is where we got this idea from. All right, I'm gonna run this. Okay, all right, so it's asking as why, yes or no, right? I'm going to push no here. But what else you could do here is, if you want to avoid this, if you're installing a lot of application, you -y. So it's going to automatically not going to ask you for that question there. Okay, so let's do LSBLK. And then, so we took care of accounting, human resource, and finance. So other one we are setting up as XFS, okay? So the command is mkfs dot xfs, okay? And then what are we gonna do? What are we gonna run the command? Okay, so you're gonna run this command here. Okay, it did finance. Then I'm gonna do recruiting. Okay, I'm gonna clear this, and I'm gonna do BLKID. Okay. Now you see all these things are setting themselves pretty good. To me, this looks beautiful to me. That's the best thing I could describe this as. Okay, everything is in place. Okay, so before I forget, let me run this command here. All right. If you could go on mute.
Zafar, I had a question about when you went to a BLKID, it said dev mapper and then ZMPT one. What's the mapper?
That's how it starts off with. If you look at the original one, even this one, it says as a dev mapper, and then this is the name of the volume group. Okay, this is VG. This is the name of the VG. This one here, volume group, ZMPT1, and then we will get hyphen, then we'll get hyphen, and then recruiting. Or
so when you create the mkfs, it automatically creates the mapper folder. Or?
Yeah.
Okay.
Okay, let's go ahead and go into the dev folder and see if it's gonna point to that. Okay, in a minute. Okay, CD. Okay. Okay, there you go. This is where it's pointing towards. Okay, this is the one that's created by the system. Okay. All right. This one says here because I'm on a different computer, and then that was the name key one when you were creating the when you were installing the operating system using the CD. Okay, remember, very first thing you do is installing from the CD. Whatever name you go, it will take that here. Okay, and then these are the ones we have physically created it right now. Okay, so what is the PWD? This is where we have. Okay, and then we could go to cd dot slash, okay, ZM. Okay, what is the path I'm using right now? Anybody?
/dev/mappers/
No, what I type
No.
on the screen, what are we?
Absolute. Because you're starting from the root from the beginning.
No, I'm not starting from the root.
That's the relative path.
Exactly. That's a relative path.
Or because you're not okay, because you're not starting from the beginning, you're starting from the mapper.
Yes.
That's why, yeah.
Okay. Okay. When I hit enter, I got out of there. Then I type LSFNL, and I see this here. So what this is this
But I have a question here. CD. If we would have used CD ZMT1, it would have done the same thing, right?
no,
Because we were already in dev/mapper.
no. You got to practice more, buddy. If you do just cd dot.
No. If we had done just CDs, then ZMT1 without slash, without that.
Where the PW would be mapper.
Yeah.
Because ZMT and mapper are in dev folder. ZMPT1 is not in mapper folder.
Okay, got it. Okay,
so I need ls here, right? I don't see that folder in here, ZMPT.
Okay, got it.
Okay, so yeah, you're getting the concept, right, guys?
Yep.
Right. This is very, very important here. If you nail this, I guarantee you're gonna be in a six-figure salary. No questions about it. This is where all the data is living and everything, and this is actually helping the data management, and everything is based off of here. Okay, when you do DFF and H, when we're going to map it here, it's not crowded here at the moment here, but it will get crowded here. You will have like about 100 entries in here. So if you don't understand here, when you go onto a job, the best thing you do is pen and paper, and then I will show you. I will create, maybe tomorrow I'll create very, very complex environment in here, and as a new person you're going in, how are we going to dissect that and tell ourselves what are we looking at, okay? So tomorrow class, don't miss it.
That will be fun.
It is fun. I mean, anybody who's not liking Linux, let me know right now. Okay, I take it as no.
You take it as no.
I'm trying to see what people are doing there.
I'm liking it. I like the challenges.
Okay. Now, you probably never saw more than one file system in Windows. Your Windows is just NTFS, I think. I don't know what else they're using. If you have NTFS on one disk, it's just NTFS on the entire disk. You cannot put more than one partition on it. Well, let's take a look here.
We can put more than one partitions over but Windows used normally by home users, and there's not much option in Windows. Only NTFS or FAT12. Nobody using FAT12 now, so it's only NTFS is only, I think, file system which people use, even in server environment.
Can you have more than one file system, did you say, on one single disk?
Yeah, you can create the partitions, and then you can have a different file system on partitions.
I didn't know that. That's good to know.
I have done long time back. I need to check, but I am positive we can do that.
Okay, good. All right, so.
But it will definitely not be any Linux file system and NTFS. It will be only FAT and NTFS, etc.
Okay. All right, so let's see here. Where are we now? So we have successfully created these partitions here. Okay. Now, what we're going to do is we're going to mount it. Okay. So everybody knows how to mount these things, right? So I'm going to go to my home directory and let me see if something is in here. Nothing. I'm going to delete all this. Actually, let me go into root. Let me see what we have here. Okay. There is nothing here, so I'm going to create folders here. mkdir accounting. Okay, mkdir / oh, I don't want to create there actually. I want to create in this directory, accounting, and then human R, and then finance. Okay, and then what I'm going to do is I'm going to create recruiting.
Should we remove accounting from root as well, just to avoid confusion?
Yeah. What is the command?
RM.
What is the command to delete a directory?
RM hyphen RM.
rmdir.
And then the
RMDIR is good because the directory is empty.
Well, if it's not empty, you can use the -p switch.
For to remove RMDIR, you could use that.
To the directory, right?
For an empty directory, you could use RMDIR. If it's not empty, you cannot. So if it's not empty, you have to use RF, RM-F. Okay, so RM-RF. Okay, why it didn't force? It's just F, so force it. So, but we are doing RF means remove force. Removing directory using RM with RF, and then the directory. Okay, so we have this drives here. Okay, so now what I'm going to do is I think I have showed you how to you do ls cat /etc/fs tab. Okay, you see it in here, right? Mounting the disk in here is using this dev mapper here. It will actually bring this up later on here, but let's try a different way to mount this and see if it's going to work. Okay, so let's see here. I'm going to mount /dev slash ZMPT1, and then I'm going to do accounting, and then I'm going to mount it to accounting folder.
You don't use the mapper in between the dev and ZMPT?
No,
Okay.
because this is actually you could use mapper also, but we're gonna use a mapper and ZMPT. They are all symlink, soft link for this DM1 and DM2, all this. We're gonna go deeper in that. What does it mean? Okay, let me hit enter and see if it's gonna work. And it did work. Okay, now this time around I'm gonna mount and then dev, then mapper, and then I'm gonna do ZMPT1, and then what I'm gonna do is human resource, and then I'm gonna map it to human resource. Okay, so it worked that way too, because this link and this without mapper, they're all pointing towards the same thing. They're pointing towards the same place, DM2 and DM4 or DM3, whatever. Okay. All right, I think I'm missing some. Okay, so all these things are mapped now. Okay. Now, let's see here. Well, what we have here is 4 drives, right? I mean, 4 logical volumes which are mounted here. Okay, so this is a new concept here. But what will happen if I restart the system?
Will be gone, will be deleted because it's not in the FS tab.
Yeah, you got the idea. So let me just okay, this looks good. And then mount. I'm mounting them now. Okay. Create respective directories, mkdir accounting. Now mount. I don't think this is necessary. Okay, all right. Okay, you want me to go over FS tab or you got the idea?
I think we have the idea.
Okay.
We use a couple of times, yeah.
Okay. Now to make it persistent, that means it's permanent in FS tab. The official term you use is persistent. If in the interview they'll ask you, what would you do to make it persistent? That's how they will ask you. And you would say, okay, for if you're dealing with either LVM or mounting the partitions, you make it persistent in FS tab, etc FS tab. Okay, good. All right. So what I'm going to do is what I'm going to do is I do dff-h, and then okay, so accounting folder is busy here. Okay, accounting folder is at 1%. It's about 4 GB. Okay, the size is about 4 GB. Okay, and then 8 megabytes has been used. And with any system, available is not going to be everything is not going to be available, because there are some things used by the file system. So the most information or most you could fill it up is this much information here. 3.7 GB is available. It's been used only 1% here. I want to look at the inodes of these. So what do I do? What's the command to look for? ls hyphen?
I.
Okay. No, it didn't give me enough information. It's giving me the information of those folders here.
You have to type H in there too. ls-hi.
Like this?
Hyphen hi, yeah. No.
No, you can use L as well, and then it will give you the list. And
Okay. No. The command is df-I. There you go. These are the inodes. Okay. Alright, I'm pretty sure I showed you to this guys here. Let me go back where inodes is. Okay, to find inode. Okay, here. This command will show you the inode information. This command will show you the inode information. I think I missed that. inodes. Okay, here. Okay, here, df-I. Okay, here's the df-I. But I should have put that in here. Find and okay. Okay, alright, I'm gonna actually put the output in here. Okay, so these are all the inode information here. All this is inode. I'm gonna remove this here because it was early on in the practice. Okay. Okay, so you do df-I here, and then on a 4 GB disk, it could create up to 262,000 inodes in here. Okay, so okay, so let me go in here. So what is the path I just used a moment ago?
Absolute truth.
Okay, great, very good. Okay, okay. Now what I'm gonna do is I'm gonna fill this folder up, because what I'm gonna show you next is I'm gonna show you how to extend the size of the partition, size of the LVM in this case. Okay, there is a command. We'll go over this lot more. What is dd command? But right now I'm just using this command we use a lot of time. dev/0. Okay, output file equals Zafar. Okay, byte size equals 4096 and count equals 4G. Okay, yeah. Okay, what is this is dd command. Okay, let's see what dd command is. dd command. Okay, dd is a command line utility for Unix, and what does it stand for?
Device drives.
Is that what it is? Device drives?
Yeah, that's what in your previous link.
Okay.
Uh,
DD command is actually take a backup of the entire hard disk. This is pretty very good command here. We'll go deeper into it. But at the moment, what I'm doing here is I'm using a DD command to create a big file. Okay, how am I using that command to create a big file? I'm using DD. IF stands for input file, and then what is the input? I'm using dev/0. Okay, this is something new. We have learned dev null, right? Dev null is a black hole, and then dev/0 is only 0. Okay, it's just a blank 0. It creates zeros into the file. Okay, and then output file, and the name of the file is Zafar, and then each size of each byte size, BS stands for byte size, and each byte size is 4K. And then how many we are creating? About 4 GB. 4 GB.
It's byte size or block size?
Oh yeah, block size. Good. Yeah. Thank you. Each block size is 4K. And then how many block size we are creating? We are creating 4 gigabytes of block size. So 4 times 4096. There are many block sizes we will create here. So what happened here is it wrote in the many records. Okay, and then this is the size it did here, and 4.1 GB is copied. Okay, so let's see what is the size of the disk actually. The size of the file itself. Okay, now we could use LS-LH. Okay, so it's using 3.8 GB, and this is a garbage file. It's nothing in there. If you carry it, I think I'm gonna error out. Okay, I mean the system is not gonna show you anything in there because what is in there is all zeros, binary. That's what it's in there. Okay, you can't really carry it. So for the demonstration purpose, what I did was I created a huge file here. Why did I do that? Just to create a blank file which is taking up the 100% of the disk size available. Okay, so if we try to create any file in here, it should give us an error message. Okay, apparently it has some space left here, but let's see if I could mkdir or dir1. There is little space available there, so but let's see. Maybe can I create 100 files in here? Okay. All right, but here. Okay, here's the thing here that we have an accounting team and somebody's trying to put a big file in there. Okay, and then they're crying about that the size is full. Okay, remember last time they were crying about the size is full also, but we checked size. The use available space was a lot more, and use size was nothing, because it was the issue with the inodes. They used up all the inodes. But now they're crying about same thing here. They will come back to you and says we are not able to create any files. Then you have to determine at this moment if it's a problem with the disk space or it's a problem with the inode. Most of the time, once you get the ticket, you type df-h and you will say which location in the ticket. It will give you the information here, which one has a problem, and you say, okay, this is full. This thing is full here. So what you're gonna do is you're gonna then before you even talk to them, what you do is you type the command vg display. Why you even doing vg display? Because you looked in here and determine, looking at this information, you determine that this is a LVM, logical volume. This is not like a physical volume, okay, because it has a mapper in it. So what you type is, you type vg display and you hit enter. Okay, before that you type vgs. Okay, you type vgs and you see this is a system volume group, and this one is the one created by us. So how we determine, we're going to look into this. You type df-h again, and you will determine, looking at the ZMPT1 is the volume group. Okay, this is the volume group here. Volume group is the parent, and accounting and all these are the children. So okay, we need to zero in on ZMPT1. Okay, so let's see. You type VGS and hit enter. Okay, now you see ZMPT1 here and ZMPT1 here. Okay, so you look at ZMPT1 and then you see here PV. Oh, okay, when you see PV it says 3 here. Why does it say 3 here?
Because you combine the 3 drives together.
3 physical drive. PV is physical volume. Very good. And then you see LV here. What does LV stands for?
Logical volume.
Logical volume, exactly. And it's telling you 4. Obviously, these are 4. 1, 2, 3, 4. Accounting, human resource, finance, recruiting. Okay, all these things are matching up. Good. Then we determine if this is 4, so here is 4 too. It may or may not be mapped. You know, finance is not mapped, so you don't worry about it. But you worry about what it's saying in here. There are 4 physical volumes in here. For example, if finance is not mapped, right? Let's U-mount it. Okay, DFF and H. You come here and see it's 100% full. Okay. Now your next instinct should be you type VGS. Okay, and you hit enter here. Okay, and you determine, okay, this one has 3 physical disks, and out of 3 you have 4 volumes in there. Now you're gonna question, I see only 3 here. Where is the 4th one? Okay, so for 4th one you type a couple commands, LSBLK, and you see in here like ZMPT1, and you have 1, 2, 3, 4. You determine this is the 4th one. Or you type BLKID also. Okay, and you determine this way also. ZMPT1, all these are the child ones here. The missing one is finance. Okay, so let me get out of here. Let me type DF-H again. So we are interested in increasing the size of the accounting here. Okay, so we type VGS and hit enter, and we zeroed it on ZMPT1. Now we look at the volume size. Okay, so the volume size, it says is 23.99 has been used up, and so let's make it 24 GB is being used up, and then 7 GB is 8 GB is available volume size. Okay, so let's go ahead and see how we're going to determine how much is available in here. Okay, this is still there here, but there is another command we're going to use, VG display, and if you type VG display, is going to give you the expanded information for these 2 here, but we're only interested in ZMPT1. Okay. So let's take a look here. Uh, okay. So here is ZMPT1 and format is LVM2. It used to be LVM, but LVM2 is, I think it's a newer version. Okay, and it says metadata areas. It says 3 here. So what is this? These are 3 physical volumes here. And it has a sequence 5. Okay, why does it have 5 sequence in here? Let's do LSBLK.
Because 2 were already created by system.
Exactly, exactly. 1, 2, 3, 4, 5. So Mr. Recruiting is sitting on 2 different places, okay? And this is DM5. Okay, it says, and here you see, this is the most important thing I'm trying to get is VG status. VG status is resizable. Okay. So once you determine this is resizable, then you could go ahead and resize it.
So basically, we are trying to add more risk to this volume group.
I'm sorry, what?
What
Yeah.
we are trying to do, we are going to add more
Yeah,
storage.
counting is 4 GB at capacity, so we're going to increase it.
Okay.
Okay, so let's do some math here, okay? But it says the volume group size is 23 GB, 24 GB. Okay, all right, we'll come to that here. But if you look down here, furthermore, allocated physical allocated size is 16 GB. Why is it 16 GB?
That we need to look at the partitions.
Exactly, exactly. You see 4 partitions, 4 GB each, like 4, 8, 12, 16. So this is where 16 GB is. Okay, plus 8 GB is 24 GB. Okay. And then 8 GB is 8 GB is free here. So 24 and 32. But our volume group size is 40 GB. So how much we are missing? How much we are missing? We are missing 8 GB here. So actually this is 8 GB. Okay, and 24. So 8 GB is still there. Volume size is 4. And then 8.
This 8 GB is out of 24 totals. What we see, 16 is already allocated and 8 is free, right?
Yeah, so it's all mapping up to
24.
A 40 GB, right? Yeah. Okay, here, let's do math here. Okay, so 40 GB is there. Out of 40 GB, volume group is 24 GB. What is volume group? Volume group is ZMPT1. Okay. Out of that, partitions are 16 GB. Logical volumes, okay, are 16 GB. Okay, so how much we have here? How much we are left? Out of 24, how much we have left? We have 8, free is 8 GB. Free is 8 GB. Okay, so this is what it's displaying here, that free is 8 GB here. But it doesn't make sense here. Where is another 8 GB? Another 8 GB is missing.
Which other 8 GB we're looking for? Was to make it 40 or what?
Oh yeah, actually here 24, 16,
Yeah.
and it is 40 GB, right? No, it's going.
No. Where the 40 is coming from?
We have the 3 drives here, right? 16 plus 8. What did I do? We have 3 disks, right? One is 8 GB physical, and the other 2 are 16 GB each. 40 GB.
Can we quickly check F-disk and see what it is?
We never use F-disk. We never use F-disk. So in here, this size of the VG is 32 GB right now. The size is 32 GB. Let's see why is it 32 GB. Okay, so here is 8 GB and here is 8 GB and oh,
System created a
yeah, system created it. I messed it up, guys, because I'm in Chicago. I'm on a different system here. Yes, in the last session I set all these up as 16 GB each. Damn it. Which one is it? Okay, yeah, these are 8 GB, 8 GB, 8 GB. Okay, by default it's doing 8 GB here, okay? Okay, and now, yeah, this is true. This statement is true here because I'm on a different computer. Damn it, I messed it up. So these are actually, but it's going to conflict with what I have showed you in the previous video. What I have showed you in the previous video. Let me see if I could expand this here. Is this okay if I change this here to 8 GB here?
Yeah, that's fine. Yeah.
Yeah, that would be fine. The total will be the same.
Yeah, but remember, I was trying to make it a little complex here, but I've forgotten about it. I think I started the wrong box here. I think I made 16 GB on something else. Oh, okay, on this box I made it 16 GB each. Did I? 8 GB. Yeah, this is the one. But this is gonna mess up when you guys are gonna practice, right? right here is showing okay, here in our last session this information is correct. Okay, it took volume group size is 40 GB, and then how much was free? So we have 3 VG display, right? Okay, yeah, 3 meta
It
sequence.
should be fine, but when we are going to practice, we are going to create a storage on our
Okay.
system, so that should match.
Okay, so let me go ahead and change this here then. Okay. All right, guys, I'm sorry about that. Okay, and okay, good. So let's put this as 88832, and then this is what it is. So it's
So the new LVM will be 24 GB, right?
30 GB, 32 GB. So over here, 24 is volume group is 24, and 8 GB is free. Let me clear this. Okay, so the volume group name is ZMPT1. So this is ZMPT1, and then it has 3 drives in there. Okay, 3 physical drives, 1, 2, 3. Okay, and then meta sequence we just saw when we did LSBLK, it has 5 in there. So um, these 4 partitions are split up into 5 sequences. Okay, and it's resizable. Okay, current PV is current physical volume is 3, and active 3. Volume group size is 24 GB. Okay, so it still doesn't make sense. Why is it saying 24 GB?
Yeah, that was my question. Is to look at your physical drives, and if they are 8 each, they'll be 24 GB altogether, which is right over there. But then again, in the free space, it shows like 8 gigabytes is still there.
And now, dude, this is 24.
Yeah.
Okay, my bad.
No problem.
Thank you. I didn't know I'm that weak in math, so I found that out now. Okay, out of 24, we are using 4 GB here, and then this is the free space. And how much is the free space? 8 GB. All right, now everything is making sense. Okay, so what we're gonna do is we have accounting here, and then we're gonna increase the size, and then available size we could increase up to is 8 GB here. Okay. Good. Let me make sure I covered all of my tracks here, and VGS. Okay, yeah. Let me VGS. Okay. Okay, good. So these are the command. I dissected the command here. This should be good enough now. BFF and check inodes here. Okay. All right. So what is the command to create? We created the command. We use this command to create a fake file. Okay, good. Okay, now we need to increase the LV for accounting. All right, right. DF-H. Okay, now the size is 4 GB is all used up. So we gotta take it that we need to increase the size here. Okay, so we use these commands to check the size here. Use VGS and VG display ZMPT1. Okay, so we use these two good commands, VGS and VG display. Okay, all right, good. Okay, so now it's very simple here. I use this command a lot. So how are we gonna do this? What is the command to increase the size?
LV extend.
Yes, LV extend. Very good. LVEXTEND. Okay, and then what you're gonna do is hyphen L. Okay, because it's a logical disk, and then I'm going to increase it to 2 GB plus 2 GB. Okay, plus 2 GB, and then what is the mount point I'm going to increase it to? Okay, I'm using this here. Okay, this is what I'm going to increase it to. Okay, or I could use dev slash, instead of mapper I could use the ZMPT1 also. That one works and this one works. Both of them works. And I hit enter. Okay. Alright, how am I going to verify that the size has been increased? Do I do df-h? Okay, I did df-h, and the situation is the same here. Okay, but there is another command that you have to resize it. So there is a resize command, resize, RESIZE to FS. That's the name of a command. This command is not new. I think I already showed you once already, didn't I?
Yeah, I think we used last time. And this is equivalent of make file system, right? In context of the resizing the LVM, right?
Yeah, it will assume whatever its file system is just resizing it. But this is not like extending the inodes here. Extending the inode, you will lose the data. Very dangerous. If you are extending the inodes, you're losing the data here. Right here, resize to FS, and then we resized it. extending in a
We checked this in the last class, Zafar, that we resized and it didn't change the number of inodes we tested in last class.
Yeah, the inodes are not going to change. This is going to change the size. And then /dev/ we used mapper last time, right? Let's try this ZMPT1 accounting, okay? And hit enter. So it resizes it, df-h. Okay, there you go. Now out of 4 GB, out of 6 GB. So we added another 2, so it's at 6 GB. And then how much is used? 4 GB is used, another 2 GB is left. It's about 70%. Okay. You will be getting this request a lot. So practice this as a second nature.
So those are a quick question. So the inode is for how many files you can create total, right? And then the space on the size too. Is that kind of the same thing, or is it?
No.
If you can expand on like what's the difference?
Inode is a number given to each file, and then I mean if you look at here, where is our accounting here? It has about 400,000. You could create 400,000 files in there. So if you create 400,000 silly files that don't even have any data in it, I could create 400,000 blank files. Okay, then it's going to take up all the inodes. But the size of those 400 inodes, 400 files could be only 1% of the entire disk space. Okay, then you will get the same message. You will get the same message that there is no space on the disk. Okay, so you gotta be careful. Extending LVM is very, very safe, but resizing the inode is very dangerous. Never ever do that here. I think I made it clear before too. Mount.
So basically, once we have created a LVM, the total number of files or directories to be created is done. That's already given. We cannot change that unless we.
You could actually determine at the moment, very first you were doing mkfs.ext4, very first time you're doing it, you could actually determine that. Yep. You actually physically give that number here. But if you are doing it once it's already said and done here, if it's already said and done, if you're doing it, then it's dangerous. But if you're doing it at the moment of creating the file system for the very first time, and you know these guys are going to use up a lot of inodes, then you just give them, you actually talk to them and see how many inodes you need. This question will actually come up when you're doing some engineering work. You will be talking with other teams, and they will actually tell you, we have some application which is sucking up inodes a lot more than the data itself. So they will tell you, give me like a 1 million inodes on this. So when you're creating the size, you could do mkfs.ext4. Remember, ext4-n, then 800,000, you normally don't give, right? You just give it the amount point. But if you give -n and the size of the inodes you need, at the moment you are thinking into the future and determining that you need a high number of inodes for this particular group. Okay.
Zafar, can we change even inode in this resize to fs command? We know that the data will be lost, but is this option available in that command, or we have to use make file system?
No, mkfs you have to use. There is no inode extension. That's what I'm saying. Extending the inode is very dangerous. So you give the maximum inode as much as you could. The system is already giving enough inodes, right? But there may be some silly files created by some weird application that may require higher number of inodes. I mean, just imagine 400,000 files. It's a lot already, don't you think?
It is.
Yeah, but you will run into a situation. There is only like the file size is 0 KB, but the system is generating those. The application is generating those files. So then they will ask you to give you the bigger inodes. So remember, when it comes to inode, you tell them, can you delete some files? You just tell them blankly like that. And if they could, they will delete it. If not, then they have to come up with a different ideas, backup or whatever.
And in real-time scenarios, of course, all these things are going through a change ticket, which goes through certain approval process, and there will be a lot of visibility.
Yes,
yes. It's not going to happen.
Exactly. Very good. Very good. Especially if it's on the production boxes, the boxes which are making money for the company, yeah, you just don't fool around with it. That's what I'm telling you. I mean, you could do it without telling anybody because you have a root access here. You have a root access here. If you end up working for Google or Apple, you have root access for their system. So you have to be careful how you use it. But you will get it with the practice. Okay. So let me capture this commands here. So we did VG display. Okay. You want the output for VG display here? I think yeah, it's over here, so you could determine that. Okay, this is the size. This is the size, and this is the used up. How much is used up, and how much is available here? Okay. So it has 4 GB left, right? So now it should be down to only 6 GB. Okay. If I type, let me just capture this before I type that. Okay, so you type, and then the command is, this is the command. Okay, you type the command. Okay, now Alright, so you use this command here. So I use dev mapper here and ZMPT1 here so that you could understand. Either or you could use it. Okay, now how are you gonna do that in the XFS file system? Okay, XFL files. What is XFS file system is different than ext4. We did it nice and easy for ext file system. How are we gonna do it for XFS file system? Anybody?
It will be the same, I guess. Resize to, instead of fs, we can use xfs.
Exactly. Okay. What am I looking for? df-h. Which one is the XFS for us here? Is finance, right? Or recruiting? Okay. Now to increase the size. I got to show you one more way to increase the size here. Okay. There you will get an option, two options here. You will get add 2 GB, add 2 GB, or extend to 6 GB. Okay, can somebody tell me what is the difference here? Add 2 GB or extend to 6 GB?
By extend to 6 GB means you are using the maximum capacity, whatever you have left over.
No. Alright, let's take a look here. Okay, for the same thing for accounting. Now the size is full again. Right? The size is full again, so we need to add another 2 GB here. Okay, so what we're gonna do is the command lv extend okay, lv extend. Okay, so right now it's 6 GB, right? But I'm gonna extend it to 8 GB.
But I have a question. Well, what if you have only 6 GB there? How come you're gonna extend it to the 8 GB?
So I got a request to add 2 GB, which is 6 GB already here, right?
Okay.
And so which is 6 GB already. I'm adding 8 GB, making it 8 GB. So when I do this here, what do you think happened? Right now it's at 6 GB. So previously it was 6 GB and then I added 8 GB in here. So what is the size going to be?
So my guess would be 8 GB.
Your guess would be how much?
8.
Yes, exactly. Adding plus, you use the plus sign here. I remember I didn't use the plus sign. I'm making 6 to 8. Okay, this is how you will get a little bit tricky here. Add means you have to put plus sign there. 2 and then extend to 8 GB means we already have 6 GB. We're extending it to 8 GB here. Okay, let's run this command here again. Resize to FS. Oh shoot, I should have run dffnh. Now you see 8 GB here. Okay, so there is a difference between here. So you will get a request, add and extend. You got to determine all that also. So here it said now we need to increase. So we using the add method plus 2 GB. Okay, and this is the extend method using the extend method. Okay, this is how you do it. Okay, all right. You think this is easy? No, it gets complicated more. But once you master this is what you're going to get paid for. Mastering what you are learning today. Believe me. Okay, now to extend XFS file system. Okay, so let's see how much size we have here. So we have another 4 GB available here. Okay, so how are we gonna extend the file system for XFS? Same thing.
XFS grows.
Exactly. Very good. Okay. All right.
And then switch capital D.
Switch capital D.
Yeah, XFS goes has options to extend the data size or percentage or etc.
Okay. Let's see if that's gonna work. All right. Let me check my notes here. Okay. We already used that command, right? XFS grows. MK multiple file in single disk. And
I don't recall. We might, but I don't think so.
extending partition. Oh, I should have showed you here too. Mount resize to FS. Yeah, okay. Good. So give me one moment here. Okay. All right. So I should have showed you here how to grow the XFS file system. Okay. So we're dealing with recruiting, right? Recruiting is XFS. Let's see. Recruiting is okay. Yeah, recruiting is XFS. So let's see here which method we're going to use. Add method. Okay. So you type XFS underscore grow. Okay. And how much? I mean, the rest of the command is same. Rest of the command is -l, and then we're gonna grow it to. We're gonna add it to 2 GB. And then what are we gonna grow to? Dev. Okay. So right now it's 4 GB. We are growing it to another 2 GB. Okay, and hit enter. Okay. So is it all one word?
No, you forgot to change the. No, sorry.
I'm sorry.
No, sorry, my bad.
The command was right. XFS grows was the right command, and I think we don't need to mention this plus 2 GB here. We had already extended the logical volume, and now we just need to XFS grows, and it will grow to the size which we have already extended. If we take this 2 GB out,
There should be 2 methods in here. All right. Okay. Hold on. Oh, okay. It's a little bit different here. So I thought it was. I usually run this as a part of a command or the little script here. So when you run it as a part of a script, sometimes you forget. Okay. The command is actually xfs grow fs file system. And then what is the mount point here? Mount point is our good old recruiting. -d and the size. How much we want to do? We are using the add method. So we're using plus 2 GB. Okay. And when we do df-h, still showing 4 GB. So then you have to run the command resize xfs to run this command, right?
-d would work as well. I think the -d after -d we need to give the new size, not the additional size. If we have given 6 GB, that
No, I'm using the add method.
okay.
There are 2
The
methods,
switch,
right?
but the switch, yeah.
Okay, what is this D is doing?
The D after D we need to give the new size. That's my understanding. It's not add.
Yeah, but we are using the add method. There are 2 methods I explained you, right? Add method and extend method.
Yeah.
Right here, to extend or increase the size, now actually make it happen using the extend method, and then here using the add method here. Okay. Okay, and now we actually have to resize it. Let's see here. Okay, I think this is the same command here.
It's LV resize.
Is it LV resize now?
Yeah.
Okay.
On Google is so LV resize hyphen capital L and then plus whatever GB we want.
Okay, good. Thank you. Is it not going to take this?
No, we need, after hyphen L, we need to give the plus GB size as well.
We already gave that information.
No, we are resizing logical volume here, right?
Give me 1 second here. LV resize. Then why did we use XFS? Give me 1 second here. Let me look at my real notes. Schedule task.
We need to use grow FS anyway after.
Okay, grow FS we're going to use now.
Yeah.
XFS grow. Right?
Access grow FS.
No, it's not working.
Now XF underscore grow FS.
Yeah,
And then the mounting point.
that's what I did. Okay, hold on. Resize XFS. Okay, so you have to do -D and then the mount point again. Cooking fix it. -D. All right. Oh, people are dropping off. Let me just see. Resize to FS is going to work. To XFS. And what is the mounting point? LV resize underscore. Okay, no. All right, guys, I think we are out of time. So we'll catch up again tomorrow from this point, okay?
Okay, thank you.
If you find something, let me know in the chat.
Okay.
All right.
All right.
Thank you.
Guys.
Thank you, sir.
Sure.